Hello, welcome students to this another webinar series related to basics of electrical and electronics engineering. Today's topic name is basics of logic gates. Myself, Dr. Ashish Moskar, assistant professor in Department of ENTC, MIT Academy of Engineering, Anandi, Pune. So let us begin with our today's discussion, that is basics of logic gates. To begin, let us define what are these logic gates. So these logic gates are fundamental building blocks of digital circuits. As we know that there are two types of circuits. One is analog circuits and another one is digital circuits. So these logic gates are fundamental building blocks of digital circuits that perform logical operations. So these logical operations are in the form of binary on one or more binary inputs to produce a single binary output. So as we know that the digital circuits understands only the language of binary, that is 0 and 1. Next, their operation is based on Boolean expressions or Boolean algebra. Boolean name of scientist, where the inputs and outputs are represented as either true, which is having the value of 1, or either false, which is having the value of 0. So as previously stated, that the digital circuits understands only the language of zeros and ones. Now, in logic gates, what does the term gate stands for? Many students do not understand what is the functionality of the word gates. So let us discuss. The term gates emphasizes their role as elementary units that controls the flow of binary information according to the predefined logic rules, which is also called as the Boolean expressions or Boolean algebra. So gate emphasizes the role of units that control the flow of binary information to and fro of the circuit. This is the simple concept of the term called as gate. And lastly, how we can practically implement these gates? The practical implementation of logic gates can be done on digital IC trainer kits by using various ICs and patch cords. Now, let us discuss the various types of ICs used in digital circuits one by one in coming slides. Now, what are the basic logic symbols? So, we will discuss near about 7 to 8 different logic symbols in terms of its diagram or logic symbol, in terms of truth table, and in terms of its Boolean expression. Now, firstly, let us discuss about this buffer. So, this buffer is an important element used in electronic circuits or electronic devices whose logic symbol is as shown in figure. It is having only one input, that is A, and one output, that is 1. Now, this truth table indicates the functional working of any of the gate. So it is having one input, one output. Suppose when the input is 0, the output will also 0. There is no change. When the input is 1, that is at the higher load or true, the output will also be 1. What is the Boolean expression for this buffer? That is y equal to A or A equal to 1. Now, let us move forward towards this inverter. So, this inverter is also called as NOT gate. Already, inverters we are using in our homes also. Let us discuss that inverter in some other video. Its logic symbol is as shown in figure. So, what is the difference between the two symbols, dear student, that you can see? As compared to buffer, the logic symbol of NOT gate is having a small bubble which indicates that it is a NOT gate or inverter. So it is also having single input and single output. A is the input, Y is the output. Now, the truth table of this inverter. A is the input, Y is the output. For input 0, the output will be high because this is the inverter. For input 1, that is high, the output will be low. Right? And finally, the Boolean expression of this inverter, Y equal to A bar, means A bar, or it is also called as A component, or it can also be written as Y equal to A dash. The meaning of both the expression is one and the same. So let us move further. Now, after discussing buffer and inverter, my third logic gate is two input AND gate. Up to now, only we have seen a single input. Now, here there are two inputs. Two input AND gate that we discussed. A and B are the two inputs, and Y is the output. And this is the logic symbol for two input AND gate. Regarding to truth table, so the truth table of this AND gate depends upon the Boolean expression. What is the Boolean expression of two input AND gate? Y equal to A into B. Means we are multiplying both the inputs to get the required amount of output. So here, truth table, just we need to multiply. A and B are the inputs. So how is the combination? 0, 0, 1, 1 for A. How is the combination for B? 0, 1, 0, 1. Means, now multiply. 0 into 0, output is 0. 0 into 1, output is 0. 1 into 0, output is 0. So for 1 into 1, the output is 1. Means when both the inputs are at the higher node, the output will be 1. Next, 4. Two input NAND gate. Now what is the difference between logic symbol of AND gate and NAND gate? As we have discussed in the previous slide, means there is a bubble present. So it is also having two inputs, that is A and B, and Y is the output. What is the Boolean expression for this two input NAND gate? So Y equal to A into B bar, or it is also called as Y equal to A into B component. So truth table exactly opposite of this two input NAND gate. So just replace zeros by ones and ones by zeros. So this is the truth table of two input NAND gate. So let us move forward. Now, two input OR gate and two input NOR gate that I discussed. So two input OR gate, this is the logic symbol. Dear student, don't get confused between the symbols of AND gate, NOT gate and OR gate. Please note it properly. It is also two inputs and one output. So what will be the expression? Y equal to A plus B. Means we need to add the two inputs to get the required amount of output. So let us move towards the truth table. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 in binary. Here you need to write down as 1. Means 1, 0 and 3 ones. Let us move towards two input NOR gate. So again, the logic symbol you can compare of OR gate and NOR gate. That is, it is having a simple bubble, right? So truth table, just reverse of this OR gate. Instead of ones, we are having zeros, and instead of zero, we are having one. And what will the Boolean expression? Y equal to A plus B component, or Y equal to A plus B bar. So this is about your two input OR gate and two input NOR gate. Now, lastly, two input XOR gate and two input EX-NOR gate. So what is the difference between an OR gate and XOR gate? Just you are having this component as extra, this semicircle as, or this curve as extra. It is again a two inputs and one output. So what will be the Boolean expression? Y equal to A XOR B. Here we have drawn this symbol plus and a round symbol which indicates A XOR B. So what is the truth table of this? For two inputs, if both the bits are similar, you can see 0, 0 and 1, 1. The output is 0. For dissimilar bits, the output is 1. This is as simple as it is. Now for two input XOR gate, if you compare the logic symbols, only we are having a bubble, two inputs A and B and Y the output. Truth table. It depends upon the Boolean expression. What is the Boolean expression? For this two input XOR gate, Y equal to A XOR B bar or Y equal to A XOR B complement. So just replace 0 by 1 and 1 by 0 in case of this truth table. So if both the bits are similar, the output is 1. If both the bits are dissimilar, the output is 0. So this is about your basic logic symbol, truth table, Boolean expression, and this one. Let us proceed further. Now, what are the IC numbers for various gates? So in this case, we are using a 74XX series, dear students. Please note, these IC numbers will be helpful for you while dealing with the practical exams on digital IC trainer kit. So for AND gate, we are using 7408 IC. For NAND gate, we are using 7400 IC. IC stands for integrated circuit. For OR gate, we are using 7432 IC. For NOR gate, we are using 7402 IC. For NOT gate, we are using 7404 IC. For XOR gate, you use 7486 IC. And for EX-NOR gate, you use 74286 IC. Now, coming towards this figure, this black portion, dear students, where 7400 is written, so this black portion is called as wafer, while this round is called as a notch. This metal connections are called as a pins. So this 74XX series is nothing but, you can say, 14 pin IC. 0 to 7 means 8 pins here, and you are having 8 pins over here. 2, 4, 6, 7. So 0 to 7 or 1 to 7 you can consider. 1, 2, 3, 4, 5, 6, 7. So 7 plus 7, it is nothing but a 14 pin IC. So 14 pin IC means pin number 1 and 2 are for the inputs. Pin number 3 and 4 you can use for outputs. Pin number 7 you need to ground so as to save your IC from getting damaged. And pin number 14 you need to apply the VCC, that is plus 5 volt. Means 1 to 7, 8, 9, 10, 11, 12, 13, 14. So this is simple structure of your IC, and this is the simple internal structure of 7400, that is NAND gate IC. I hope it is clear, dear students. And lastly, let us move towards the applications of digital ICs, where these digital ICs that we have discussed till now are being used. So some of the applications included are in computing systems to develop microprocessors, microcontrollers, memory chips, as we are having the memory cards of XYZ GBs. In communication systems, we also use these digital ICs in design of modems, that is modulation and demodulation, for design of DSP processor, that is digital signal processing processor, also in design of few network switches and routers. In consumer electronics, in design of smartphones, digital cameras, televisions, gaming consoles, we use these digital ICs. In automotive systems, in engine control units, for example, the smart EVs, the dashboard displays, the airbag controllers, we use the applications of digital ICs. In industrial automations, in PLCs, that is programmer logical controllers, to make everything